United States Department of Agriculture.
The order of the program today is as follows. First, we will delve into the realm of generative AI and its implications for future scholarly research. Our expert from Ithaka SNR will explore AI literacy, the AI product landscape in higher education, and its long-term implications. Next, a computer and data scientist in agricultural research will explore the critical need for comprehensive data archives to support scientists in their research endeavors. She will share her perspective on AI workflows and related challenges and strategies for maximizing researchers' time while using AI tools. And then after our ag data researcher experience talk, we will hear online remotely from New Haven, Connecticut, from a research and education librarian at the Yale Medical Library about their experiences and initiatives in integrating AI technologies into evidence synthesis screening and active learning for systematic reviews, or ASRs. And finally, we will turn our attention to the National Library of Medicine and explore the innovative AI applications they are implementing to advance healthcare research and information dissemination in the U.S. government context, with an emphasis on generative AI use cases. Throughout our discussion, we aim to provide valuable insights into the transformative potential of AI in its various forms in research libraries. After the webinar, we will post the talks online, as well as provide other online resources. And I know at least one of our presentations has a number of resources in it, including policies about generative AI in the federal government context, which we will not go into great detail about today, but we'll cover some of the work that we do here at USDA, ARS, NAL, as well as the National Library of Medicine and their approach to these types of work. So again, thank you for being here for National Library Week and for this panel discussion on AI and research libraries. Thanks also to our panelists and the NAL Employee Engagement Council, and in particular, Jessica Alt, for getting things organized for us today and for making everything happen. We hope you will find this morning's discussion enlightening and inspiring. So I'm going to introduce our first panelist, Dylan Ruediger. He is a senior program manager for the research enterprise at Ithaka SNR, a not-for-profit research organization where he leads a team helping universities, funders, lawmakers, and scholars develop evidence-based responses to the technological, cultural, and political change that shape the production and circulation of scholarly knowledge. Prior to joining Ithaka SNR, Dylan coordinated a national initiative to better align doctoral education with changing professional opportunities within and beyond the academy at the American Historical Association. He holds a PhD in history from Georgia State University and a BA in critical theory from Hampshire College. I would like to introduce Dylan. Come on up. And yes, thank you.
Thanks. It's nice to be here today. I'm excited for this opportunity, and having never been to the library here today, I'm really looking forward to the tour afterwards. I work a lot of times with librarians, but I don't actually get to be in libraries very often these days, so this is pretty exciting for me. My name is Dylan Ruediger, and I manage a program at an organization called Ithaka SNR. If you're not familiar with us, we're a not-for-profit research organization that is affiliated with a larger organization that you probably do know because they operate JSTOR. Ithaka SNR's mission is to help academic and cultural communities to navigate change and to understand how the context for knowledge and knowledge creation and circulation are changing. And my team focuses specifically on issues related to the research enterprise. So we do research on research, and we help universities and funders and publishers and other people kind of in and around academic research to understand the needs of researchers and create a healthy and vibrant research ecosystem and infrastructure. And as you might expect, these days, a lot of that let's see. There we go. A lot of that work has to do with generative AI. So I'm going to talk just very briefly about a couple of the projects we're doing that will help kind of contextualize my remarks. The kind of flagship endeavor in the first project that we launched in this respect was a partnership with 19 research universities in the United States and Canada, who we convene pretty regularly over the course of the next couple of years, with the idea of helping them to develop strategic frameworks for thinking about how to integrate generative AI into the core missions of the university: teaching, learning, and research. And so we're working with a lot of mostly research universities, but also some smaller institutions to help them understand how students are using this, how instructors are using this, how researchers are using this, and what kind of policies and best practices and cultural norms universities should be trying to foster to make sure that AI is integrated in ways that are useful and conducive to learning and research rather than distractions from that. As you can see here on the slide, and I won't belabor the point too much, but we are an organization that is committed to circulating everything that we learn publicly. So we regularly report out what we're learning from our partners who are also doing research and developing initiatives on their own campus. In addition to this project, we're also just completed a international survey of biomedical researchers about their use of generative AI, and have a number of other programs that we're doing to really try to dig deeply into how researchers use these tools. Did it right. The thing that I really wanted to share today, since I had limited time, is just one key area in which we're finding a lot of concern. There are certainly individuals, students, and researchers who have quite a bit of expertise around generative AI and how it works. But broadly speaking, every study and survey that has been done has shown that levels of literacy about the very basic mechanics of what's happening when you type in a query are quite low. And this is something that universities are really having to start to think very carefully about. How do you foster AI literacies within these communities? For researchers, it's particularly important because otherwise you're working with what is essentially kind of a black box. I chose to highlight this one because this is a place where libraries really have a lot to bring to the table. Libraries have traditionally been quite active in issues related to information literacy, data literacy, and other forms of literacies, and have really well-developed mindsets, programming, and a clear framework for helping institutions navigate these kind of challenges, alongside other issues like copyright and plagiarism that are things that libraries do very well, that are central issues to how AI is emerging. And one of the things that we're seeing with the universities that we work with is that libraries are very central players in the way that generative AI is playing out inside higher ed. They have a very important seat at the table. They're often out in front of a lot of other university offices in terms of their capacity to quickly adapt programming and develop resources to support scholars who are doing their work. As a spinoff to the project that we've been doing, we heard consistently from the universities that we were working with, that one of the big challenges that people in, say, a research office are having is just trying to understand what tools are out there, what they do, and whether or not the universities should be supporting specific tools, should be prohibiting the use of others. So we've developed this thing we call a generative AI product tracker, which keeps track of tools and applications that are using large language models that are either marketed for researchers or students, or that we know are being used widely by them. This is a freely available resource. If you're interested in it, you can find it on our website. But I think, again, what makes this particularly interesting for a library context and a library audience is that you can see that right now, an awful lot of what's going on in the generative AI marketplace are really things that are central to libraries and librarians and how they approach things. The biggest and most single flourishing category and the most mature in a lot of ways of generative AI tools has to do with kind of augmented and enriched discovery tools. And again, I don't think I need to tell anyone here today that this is something that libraries understand probably better than anyone else in the university, the long arc of technological change and how that's shaped how we find, locate, access, and digest information. This is a place where generative AI does have some fairly radical long-term implications, which I hope we'll get into today, but really do come down to some fundamental questions about the relationship between searching for, understanding information, and kind of cognitive processes that are central to understanding the relationship between research and learning. There's a magic spot. But I don't know where it is anymore. Well, I'll just say, by way of closing here, because I think I'm running low on time, can you move the slides? Awesome. Can I go to the next slide? Sorry about this. A little technical glitch. It's probably the fire alarm that did it. I guess the last thing that I'd really like to say is to just reiterate that libraries are really going to be important here. Libraries are the people that understand the information economy and the knowledge economy. That's what librarians do. And that's really the primary thing that's at stake when we're talking particularly about generative AI. We have a new technology that has been the first form of AI to jump from being a relatively specialized research tool that's accessible to a small number of people, or else we interact with it indirectly through a search bar or something like that, into a consumer tool that is accessible to very large numbers of people. And because generative AI has the capacity to summarize and synthesize and otherwise shape very fundamentally how we think and what cognition looks like, those questions about how we organize and understand knowledge are going to be really central to how the kind of cultural encounter with generative AI plays out. I'm not going to try to answer that question today, but I will just very briefly note that if you look at the longer term implications of how this is going to play out in terms of researchers and their use of generative AI, there's a couple of things that we're really seeing already beginning to play out. The first is that there are real opportunities here to improve research integrity in science. This is something that obviously is a problematic area right now in our research cultures. And publishers are very rapidly building out tools that allow them to screen for research integrity, to check whether charts or images have been manipulated, that have real potential to help kind of the policing of the boundaries of academic misconduct. You can see, on the other hand, that this is one of the great risks of generative AI as well, because the tools really make it that much easier to engage in academic misconduct and to cut corners and to falsify things. Where the balance of that's going to play out is going to be one of the things that I think we're going to see in just kind of a continual loop of like playing catch up and seeing who's in charge, who's out in front in any given time. You can read some of these other things yourself. There's time-saving opportunities, but there's also questions about when saving time becomes detrimental to the kind of deep learning and understanding that we want researchers to be engaged in. And I think maybe one thing I would point out here, since agricultural research can be very interdisciplinary in a lot of ways, is that one of the most exciting opportunities from my perspective is that generative AI may facilitate real interdisciplinary research because it has the potential to lower the bar to gaining new knowledge and a foothold in unfamiliar fields and understanding the literature relatively quickly. There are some problems with that in practice right now, but it's a place that I think is really exciting given the amount of energy that major funders like the NSF and others are putting into kind of convergent resource. I think this is a real potential enabler of that. I think that's probably about my time. So I will just throw these out there as breadcrumbs that hopefully we can pick up later. Thank you.
Thanks again, Dylan. Our next speaker is Dr. Alakananda Mitra, and she is a research assistant professor at the University of Nebraska-Lincoln and is a visiting scientist at the USDA Agricultural Research Services Advanced Cropping Systems Laboratory here in Beltsville. She earned her PhD in computer science and engineering from the University of North Texas in 2022. Her research interests include the application of AI, machine learning, and deep learning, computer vision, and edge AI in smart agriculture and multimedia forensics. Currently, she is working on AI-based crop models, tiny machine learning devices for plant disease detection, and the application of federated learning in smart agriculture. She is also working on a project for developing crop and soil simulation models, graphical user interfaces, databases, and other suitable agroclimatological modeling tools for the Advanced Cropping Systems Laboratory. Dr. Mitra received numerous academic awards and honors and travel grants throughout her academic career. During her doctoral research, she received the Outstanding Early Stage Doctoral Student Award. She also received several Best Paper Awards, and currently she has 1 U.S. patent pending and 1 U.S. provisional patent. So welcome, Dr. Mitra. Take the whole stage.
Good morning, everybody. Thank you, Paul, for a nice introduction. Okay. Can I have my slides? Okay. So today we are here to discuss about the navigating the future AI applications in research libraries. I am an AI researcher, so I will be discussing need for data archive. Next slide, please. So when we talk about AI, we know what is AI, but there are different terms we use: machine learning, deep learning, computer vision, big data. So those are kind of interrelated. So before going into the main topic, I will just say what are those. If we assume AI is a big umbrella, machine learning comes under it. So it's a kind of a medium umbrella. Deep learning, a small umbrella under that. So those are kind of subsets. Then comes the computer vision. Okay, I have not done the slides. You can go back to the slides. Yes, thank you. So machine learning is something where we give the input. Like we know these are the inputs we'll be providing. These are the features. The machine learning algorithm says, okay, this is the result. So it is kind of semi-automatic. But when we talk about complete automation, totally automatic, then comes the deep learning, where we give the input, it does what it does, and then we get the output. Computer vision, what is that? Image. We apply machine learning, deep learning, comes the computer vision. And big data, the name suggests, huge amount of data, which we apply in machine learning or deep learning. Next slide, please. So one thing we always say, why in 1950s, basically, AI came in first. Then it took 70 years to reach that phase. Why it took so long? Because we had the AI algorithms, but we didn't have the proper hardware. Then, maybe 20, 30 years ago, NVIDIA starts making the integrated chips, which are AI, makes AI more to flourish. Then the final thing is data. Data, we know AI, ML, and deep learning models are data-driven models. It means it gets the information from the data and it says it. Basically, a machine learning model, what it does, it gets the data pattern and it predicts the output. But one thing we have to admit that all the machine learning models mostly are data guzzling. They need lot of data. We know the large language models. We use it. Some, at least at home, we can use it, not in our office. Those are we cannot use there. But what I see that when I am using that, my data is going there. So it is not private anymore. So it needs lot data. Users are inputting the data, it getting trained from that data. So that is the problem. Next slide, please. So how AI work? There are two parts, data part, AI part. Data is generated. Like anywhere it can be generated. Then we store the data. When someone is working on AI, they process the data. What they do? Then they train the model with those data and they predict it. So that is the two parts of AI. One is data part and one is the AI part. So for any kind of AI, data plays a significant role. Next slide, please. As I said, every event generates data. Like I am talking right now, I am generating data. Like my words can be used using in any kind of natural language processing input data. I am talking to an audience. There are at most 120 people in the virtual audience, as the virtual audience. I'm a little bit stressed. My vitals are going up. So this kind of data, if they check, they can use it for any kind of experiment. But nobody is collecting my data. So these data are lost. But there is a solution. What is that? IoT sensors. So those IoT sensors basically collect or detect the data. So it collects so much of data, it becomes huge. It originates the big data. So, okay, data is there. So what's the problem? There is some problem. Next slide, please. What is the problem? Data quality. It does not mean we have to have always very large number of data. We have to have a quality data. Then data scarcity. Okay, I am contradicting myself. There is big data. Then how come the data scarcity? I will tell one of my experience. I started working AI with the image forensics applications. There we had data, but when I moved to agriculture, smart agriculture application, I found out there is hardly data people can use for AI models. So data, indeed, there is some data scarcity. And without data, we cannot go forward. So there is a stop. Data unavailability. Lot of universities, lot of research laboratories, they are generating the data. But those data are private data. Students, researchers, they cannot use some data. So even if there are some data, those are inaccessible data. And some data, they are scattered. There are a lot of sources. I remember when I started working, there are a long time I had to find the data and what data I'm getting from various sources like Kaggle or Mendeley data repository or AWS data repository. I have to plan my research problem that way. So that is a big stop between when we are progressing AI. Next slide, please. But I am not talking about all the problems. I have solutions. What are the solutions? First, we know large language models, right? These are like, they need a lot of data. But right now, Microsoft is working small language models like Phi, Orca. Those are very small, not very, but compared to the large language models, those are small models. And they are getting trained on synthetic data, generative data, which are getting generated through generative AI. Dylan talked about the generative AI, right? So he talked about the synthetic data and all those things is very needed. Why? Because I recently worked in a project, it's crop yield project, okay? We were trying to predict the crop yield, but we are not getting the enough data. So we used an USDA model, cotton model, it's called GOSIM, to generate the synthetic data. So then I can predict the yield. So those kind of synthetic data generation, we have to do more so that we can do. Next, of course, the open source data. Open source, without open source, no research can go forward. So that is one thing. Then data comes from various, the previous slide, please. Yes. So of course, the collaboration. collaboration between laboratories, collaboration between university or nations. We need those to forward the research. And finally, the national level data archives. Next slide, please. So what is data archive? Data archive is the same as the book library where we can save the digital data. Yes, we have in USDA, we have the data archive, but those are not good enough for an AI work. We need more data. Yes, we can collect the data so that everybody can work on those. We have to generate the data synthetically. There are different generative methods we can use to generate that kind of data. But when we are generating the data, we have to be careful that we are generating not any biased data or any unclean data. So those kind of techniques or strategies we have to follow. And those data, of course, the archive must be in a big umbrella. So anybody, anywhere, they can access the data, not from a specific library. I don't know that is possible or not, but that's my vision as a researcher, that it will really, really help the researcher. Like in Utah, some kids is sitting in a countryside and he wants to do some experiment or some AI work. He has the internet, he has the Google Colab. So he cannot do it because he doesn't have the data. So he needs to get that access. So then we can work on the research more. Next slide, please. So data archiving facts. Of course, when everybody is getting the data, we have to have the security level, privacy level, very, very high. Malware protection. Otherwise, there is a problem. We can use distributed ledger or blockchain, which makes the data integrity keeps the same way, so that anybody is getting the data, it is time-stamped. Anybody tries to hamper the data, then it is getting time-stamped. So that's way we can safeguard our data. And of course, national policies, those are of course needed. Without regulation policy, we cannot control this kind of digital thing. Next slide, please. Of course, we always work, as Dianne mentioned, this is AI age. We have to know, we have to be AI literate. But to do that, we have to get proper AI model, unbiased AI model, so that we need to have clean data, unbiased data. Those are work for researchers. But as from the library side, what we can do, we can store the data, we can help the researcher to build up the archive so that anybody can access that. And of course, there will be less chance of misuse. And the most part I like is, as a researcher, I like to save my time. So I like to optimize my time. That will be optimized in that way. And I'm done. Thank you. You can, next slide, please. You can connect me in my LinkedIn, or if you want to need to like know my work, you can go there too. Thank you.
So two things before we go to our next speaker. One, if you have questions here in the audience, get them ready in your mind. We've got two more speakers to go. And then as well, if you're online, one of the 120 or so folks that are online, feel free to put those in the question and answer or in the chat feature. We are now going to go to our online presenter, Kate Nyhan, who is a research and education librarian for public health at Yale's Cushing-Whitney Medical Library, and a lecturer in environmental health sciences at Yale School of Public Health. Her research interests include the use of evidence in languages other than English in evidence synthesis, the information behavior of the public health workforce, and research waste. Kate co-founded the Librarian Peer Reviewer Database, which helps handling editors find librarians to peer review evidence synthesis manuscripts, and the not-for-profit organization Community Access to Ventilation Information, which helps public libraries empower community members to measure and improve indoor air quality. So with that, I'm going to transition to Kate, who is not in the room, but should appear on the screen momentarily.
Thank you very much, Paul. And thanks to everyone who made this tech setup work. I'm Kate Dianne. I'd like to thank the National Agricultural Library for the opportunity to share my thoughts on today's topic, the applications of artificial intelligence in research libraries. In particular, I'm going to discuss how librarians can help library users decide whether and how to use AI tools. And this is a natural extension of librarians' traditional role, helping library users navigate the information ecosystem. I want to stipulate that when I say AI, I mean more than just generative AI. I include not only large language models and neural networks, but also machine learning and natural language processing. Software tools built on all these tech stacks are worth talking about. And in my opinion, some of them are even worth using. When I'm deciding whether and how to use a tool, or helping a library user think through a decision they need to make, there are 10 topics in my checklist: acceptability, bias, energy, ethics, performance, price, privacy, reproducibility, transparency, and usability. Now, I'm not claiming that these concepts, adding up to a convenient round number, are the last word in evaluating AI tools for research use, but they are the discussion points that I've settled on through years of reference interviews with library users and discussions with collaborators and evidence synthesis and meta research projects, starting when I was the early adopter, cajoling collaborators to dip a toe in the murky waters of semi-automated evidence synthesis, and still today when I'm the Luddite, arguing caution about the wholesale adoption of novel but poorly characterized tools. I'm going to review all 10 items from my checklist, but first I need to point out that discussing these items is most helpful in practice when you have a specific context, a specific research task that you can accomplish by using a specific AI tool. Here's some examples of research tasks like finding papers to learn about a topic, and some examples on the right of research tasks that arise in the context of evidence synthesis, that is, systematic reviews, scoping reviews, evidence maps, tasks like screening thousands or tens of thousands of citations to identify a small set of relevant documents. Some of these research tasks have low stakes. For example, getting recommendations about which papers to read. As long as the recommendation engine software is not the only pathway by which I can discover new papers, maybe I can accept a relevance ranking system with probably good enough performance, even if it's low in transparency, assuming that it suggests papers that are at least both real and related to my information need. But other research tasks have high stakes. For example, a small mistake in a systematic review process could mean that some relevant data goes unnoticed, which could mean that the systematic review findings are wrong, which could mean that an influential clinical practice guideline is wrong, affecting patients and providers in real life. When the stakes are higher, I rely more heavily on my checklists. So let's talk about these checklist items. Acceptability is about trust or perceived trust. The Overton window of acceptable use of AI in research looks different from month to month and in different disciplines. Because of those changing and diverse expectations, I can't give general advice on this point, except to encourage you to read not only primary literature using AI tools, but also pub-peer comments, referee reports from journals with open peer review, and other critiques or evaluations of that primary literature. If it's possible to structure your work with a novel AI tool as a registered report, a publication format where the peer review happens at the protocol stage, that could save some frustration. It can be hard to draw strict lines between bias and other items in my checklist. After all, can a tool be said to perform well or to be ethically acceptable if its output is biased? But because AI tools reproduce the bias that was present in their training data, it's a crucial factor to consider. And it's a factor that librarians have always been, or should always have been, bringing up with library users. If a research resource contains only scholarly journal articles from high impact factor journals based in high income countries published in English, that's a potential problem. Whether the research resource is a traditional bibliographic database with lexical search or an innovative recommendation engine with relevance ranking algorithms based on natural language processing of abstracts and citation statements and machine learning analysis of citation graphs. The energy consumption and carbon emissions and water usage of today's technology is large and growing, but it's not distributed evenly. Lucioni and others examined the energy cost of training and running various models, including zero-shot general purpose models for various tasks. They found that generative tasks are more energy and carbon intensive than discriminative tasks, and that using multi-purpose models for discriminative tasks is more energy intensive compared to task-specific models for those same tasks. We'll come back to this idea of contrasting general-purpose tools with tools designed for specific use cases. We've touched on bias that can percolate through AI tools, making their implementation unethical. In addition, I like to reflect on the working conditions of the contractors who helped train a model and the legal framework whereby training data was acquired. Measuring the performance of AI tools can be challenging, especially for zero-shot models, but let's think of a simpler case, like a machine learning classifier designed to speed up evidence synthesis by distinguishing between potentially relevant documents and irrelevant documents. This is a use case where it makes sense to measure traditional information retrieval metrics, accuracy, sensitivity, specificity. But these metrics are part of a larger picture. Perhaps a human-in-the-loop machine learning system after setup can save 50% of the screening workload. Is that worth it? If the screening workload involves tens of thousands of decisions, there will be a big time savings. If the screening workload is smaller, hundreds of decisions only, then maybe a manual approach will be faster overall. This dynamic where the output of an AI tool requires human review is common across many AI technologies, including generative AI for coding, generating manuscripts, generating figures. So I encourage people to consider not only how fast the model will run, but also how much time and effort they will spend integrating the model output into the actual deliverable. Item 6, price, or perhaps you should say cost. The price that users and institutions pay for AI tools might be zero for now for some tools, but given the underlying cost, it's hard to predict how long prices will be subsidized. Tools that are free or affordable now might not stay that way, so think carefully before building a long-term research agenda or planning a long-term research support service. Privacy is a top issue for library users I speak with. They feel a responsibility to protect the data of their research participants, and they want to protect their own data too. That's presumably why institutions like mine have gone to the trouble of negotiating privacy-first licenses with service providers like Turnitin, whereby papers submitted at Yale are not stored in the larger Turnitin repository. Library users who value reproducibility tend to have some concerns about AI tools, as do AI experts. Reporting guidelines about AI have proliferated, with the Equator Network collating 17 different AI reporting checklists just for research into human health. It's up to editors, peer reviewers, and readers to evaluate research using AI tools and not to be content with what Casey Bennett called shallow, unreasonable justifications for not sharing information. That brings us to transparency, not only reporting the methods and results of research using AI tools, but also transparency about the models, the training data, and the test or validation data. Timnit Gebru's datasheets for datasets is one approach to documentation and transparency, But in my experience, few AI tools come close to that level of transparency, even tools that are being marketed to researchers. And finally, usability. For low-stakes tasks, usability is a huge factor in whether library users spend more than 3 or 4 minutes on a novel tool. So this checklist, I hope, can give you a framework for decision-making about AI tools in your research or research support practice. To think through those points, you'll need to seek out information that AI tool vendors or creators should, but often don't, disseminate widely. Librarian skills at critical appraisal and lateral reading are a great fit for this information need. And for more guidance, I commend to your attention the valuable resources listed on this slide, any of which I'll happily discuss during the Q&A. Thank you.
Thank you, Kate, from New Haven, Connecticut. And do hang around for the questions and answers at the end. Our next speaker, our final speaker, is Dianne Babski. She's the Director of User Services and Collections at the National Library of Medicine. She is responsible for the overall management of one of NLM's largest divisions, including the national network of more than 9,000 academic, health science, and public libraries and community organizations. Ms. Babski serves as the Scientific Review Administrator on the Literature Selection Technical Review Committee, a federal advisory committee responsible for recommending journals for inclusion to Medline. She led a 3-year data science training program at the National Library of Medicine to help staff understand the value of data science and identify opportunities to strengthen the library's proficiencies in data curation and use of analytic tools while furthering anonymous research practices and services. Under her guidance, this program has become a model across all federal agencies who are looking at this type of work. Currently, Ms. Babski leads a pioneering generative AI pilot project across the National Library of Medicine, leveraging cutting-edge generative AI technologies. This endeavor seeks to unlock novel pathways of research, streamline operational processes, and elevate user experience across all sorts of different NLM resources. And the 10 use cases she'll talk about will just be stunning. Dianne holds a bachelor's in biology and a master of information management from the University of Maryland. She and I are both proud alums of the College of Information Studies. And with that, I'd like to invite Dianne to the podium.
Okay, thank you. Thank you, Paul. And I am very excited to be here on the other side of the Beltway. And I had a very smooth ride into this morning, so that was really a nice extra benefit. So I am the director for the User Services and Collection Division at the National Library of Medicine. And we just recently reorged. So we are rethinking our future and how we are going to fit into our new NIH director's vision, which I'll talk to you about very briefly. As Paul mentioned, my background's in biology and information management. I was one of the original webmasters at NASA back when Netscape was the web browser. Remember that? Dating myself. Anyway, so I've always been into data. When I came to the National Library of Medicine, I got into data standards, health data standards, and it took this long in my career for those to be rolling off of everyone's tongue and the possibility of interoperability. So I feel like I need to drop the mic and move on so the next gen can take over. Anyway, so I'm no longer a programmer or developer. I can't even compete in that arena anymore. My job now is to really reduce barriers and open doors and possibilities for my staff. I work with a hugely innovative group of people, both at the National Library of Medicine and across the NIH. And it is just inspiring and stimulating and frightening all at the same time. Let's move on to the next slide, please. I'm just going to go ahead so I don't run over time. All right, so NLM, we're a global leader in biomedical informatics and computational health data science, but we're also the world's largest biomedical library. As Paul mentioned, we house the network of the National Library of Medicine. I like to call these our little satellite offices that help to spread NLM products and services in across the country and really into our user communities. We are one of the 27 institutes at the National Institutes of Health. So this means that we not only support research in the intramural environment, but also extramurally with grants and things like that. I'm also excited to share that we have a new NIH director, Dr. Monica Bertinoli, and she is very interested in NLM and reimagining NLM as the data science hub of the NIH. Let's move on. So there's 5 national libraries, and I've noted this on the NAL website. So NLM, NAL, 3 more. Yeah? Excellent. Gold star, excellent. When I ask that in other forums, this blank stares at me. So thank you for knowing that. Anyway, we do have a lot in common. We mostly work across with NAL and the Library of Congress. We do work together to look at our collections and what we're doing. We like to share our information management strategies. It makes sense. We look at what we're collecting so we're not duplicating too much, although you will see a little bit of overlap on here as well. Let's move on. Next slide, please. So our long-term vision, so stay with me now. Our long-term vision is to establish ourselves at the National Library of Medicine as the premier interconnected knowledge hub, providing tailored health information to anyone who crosses our threshold. So like many here, most of our users are not typing nlm.nih.gov to come into our resources. They fall into us from web searches. So really, that is our target. And how do we get people to what they're trying to find? Instead of saying, oh, go to PubMed or go to this resource. People don't care. They just want to find it. That's what I do when I'm online. I'm sure that's what all of you do when you're online. And if you don't find it, you just move on. So, the thing is that when we have users come in, you know, we envision a time when they'll have kind of this personal assistant. You type in your information, we'll take you to where you need to be. If it's working for you, then we'll, may expand on things. But really, we're at this point, this inflection point, where we can really customize information and access to a targeted user. People always ask, who's your users? Everybody. It's everybody across the globe. So we can't just keep on developing for researchers or clinicians or for librarians or for the public. Really, it has to be accessible to anyone from anywhere at any time. I'm saying this, we don't like this. If you have a better word for this, please bring it on. So we're keying this as being the one-stop shop of trusted authority information for all of NIH. And that is our potential goal in all of this. Next slide. So you've already heard a little bit about, thank you right there. So just artificial intelligence, really in short, it's just, it's a broad idea of computers that can learn and make decisions in a human-like way. You see the other things layered on top of it, like deep learning, natural language processing, machine learning. And now we have a new layer on top of it, Gen AI, generative AI, which has emerged as a new branch in AI that focuses on creating entirely new content, images, text, music, videos. So we see this as a conversational access point. Let's move on to the next slide. So we have a ton of things going on, and I brought this so I don't get out of control. Because as Paul knows, you get me started and I can keep going on this. All right, we're going to stay in the time frame. So one of the cool projects that we're doing that's really looking at pattern recognition and deep learning is our imaging clinical decision-making tool by one of our researchers, Dr. Samir Antani. So he's pioneering algorithms to detect abnormal cells in images with a focus for early detection. He's looking at cervical cancer, sickle cell, and tuberculosis. And one of the cool outcomes of his project is that he was funded to deploy these roaming vans across Africa to detect just-in-time TB and doing lung scans where it would pick up on these anomalies. So it's a really great use case that's actually in practice. Next slide. So aligned with NAO, we also went to automated indexing. So we created an algorithm, I want to say it was back in the 80s, and we have been refining it for many years because it was that, loss of humans in the loop with this. We did a lot of consistency testing. And I hate to say this out loud, but the computers are actually more consistent than when you have multiple humans applying mesh headings to the same articles. So in 2022, we flipped the switch and we went to fully automated indexing. Now, that's not to say we don't have our humans in there because they're developing the algorithm. Every day, new terms come in the biomedical terminology arena. So we have to have them in there. They're also training it up to understand additional types of articles that are popping into the literature as well. The algorithm, our newest algorithm is called MTIX, Next Gen. And it yields a better performance in precision and recall. So we're really excited about that. It's been trained on millions of index citations that were both machine and human indexed. Why are we doing this? Well, before it used to take about 180 days on average to get mesh added to a citation. Now it's less than 24 hours. As soon as the publisher submits it, we add the terms on there and it is now more discoverable. And if our goal is to make things more discoverable, I think we're hitting the mark. We do watch our precision and recall, and we do continue to have our staff reviewing the algorithm and any kind of anomalies that might pop up for training purposes. All right, let's move on to Gen AI. So back in November, actually it was probably October, I had staff coming to me. So I was at a conference and this new tool came up, PubMed GPT. And so my first instinct was to go after them for copyright and infringement. And so little did I know it would take me down a very deep hole of GPT. And they stopped calling it PubMed GPT, so yay for that. But this was a group out of Stanford that created a PubMed GPT that was using our data behind the scenes to respond to medical exam questions really effectively. So in learning about this, all of my staff had heard about this. We all wanted to get in there and play with it. And luckily we had access to STRIDES initiative. And you're going to ask me what that stands for. Somebody be a good information professional, look that up. Anyway, it's a cloud environment that is available to NIH and researchers. And one of the instances in there is access to the Microsoft Azure OpenAI tooling. So there's 10 use cases in here and we had to cap it. Originally, I was going to go for 5, but due to popular demand and looking at the different categories, we opened it up. So what have we done here? Everyone's beating down the door to try new things and test out new things, which is really cool. As you can see from the color coding, which probably is not 508 accessible, my apologies, but you can see on the left side, there's categorization. And we put these together because we wanted to, in our first pilot, think about the different types of applications for this tool. So we have everything so we have active prototypes right now that we're testing and playing with, which is totally cool. And many of these are non-techies that got in there and played and learned Python and working in Jupyter notebooks. We're not using the open web chat GPT model that you can just get into with the box. We are actually in an Azure environment. My hope is that by the end of the pilot, we're going to have a clear idea of what works, what we're going to roll into our production cycle, what we need to put a period on and move on, and then maybe some additional pathways into the pilot. Let's move on to the next one. So in this, we have everything from responding to our customer service, people writing in all kinds of languages with all kinds of issues, and it's responding at a 70% accuracy rate. So what we're doing is we programmed it to look at our own data. So go to PubMed, clinicaltrials.gov, and Medline Plus and respond to these questions. So it's not just making stuff up. Our hallucination factor is pretty nil because we're not just using an open system. We're actually using APIs to draw on the large language model. We also have another one that's transforming our metadata. I don't know about you, but 95% of our work is curation and taking data that's coming into us, reformatting it and putting it into our systems. And one of the use cases is transforming metadata to go into several different of our applications. And we see that as a huge money saver because it's just so labor intensive. And, I can really see multiple zeros per month being saved on not having to do that with staff. Because of the popularity of our use cases, NIH got involved with it. And so I'm now co-chairing an entire NIH community of practice for Gen AI. And within 1 month, we had over 500 people joining us. It is just a little out of control, but the excitement and everyone sharing and collaborating is just really a wonderful experience in my career. Next slide. So let's talk about some lessons learned. Because, this is not just a happy place to be. There was a lot of work and a big heavy lift and a big safety net underneath it. So I like to call this my wave because sometimes I feel like I'm surfing a wave and it depends on the pitch of it that day. It's not clear or straightforward when you're in this process. So one of the lessons that we learned is the value of good data. So NLM is known for creating good, normalized, structured data that's semantically linked and aligned with standards. So that took us through a lot of barriers of using our own data. This is not a plug and play arena. This really takes understanding data science principles and especially understanding using Python and working in Jupyter notebook environments. We've also had to learn a lot about prompt engineering and retrieval augmented generation, RAG. I've learned a whole new vocabulary in doing this, and it's actually kind of entertaining. We've also come to lesson number 2. You come into this with your use case and idea of what you want to do, and you have to be able to pivot and redirect. It's not completely straightforward, and what you can actually do might just be a piece of it, and you have to split things out as you go. So there's all kinds of different tools that you can leverage for in these AI systems. There's techniques, libraries, patterns, open source, closed source models. Right now, we're using a large language model. We really want to work with Google in their biomedical domain and see if that actually makes a difference in our results. And as you know, there's also hiccups that come along the way. I'm sure everyone heard about Gemini's little hiccup with their inaccurate historical images last week and had to shut it down. So, we had to go on a little wait before we could get back into our systems. And last, we must also develop AI skills in our workforce. I am a huge advocate for skill development and training. We, as mentioned, I led a 3-year program at NLM to get everyone, whether you want to just learn what data science, the definition is, to some of our researchers that wanted to get, more into mathematics or statistical analysis and things like that. So what we need to do is make sure that we actually have our human and our content people that are looking at the results. You have to know what you're getting in your results and make sure that it actually makes sense. As I said, we're working in a secure firewalled environment, so it's checking for PII, personally identifiable information, personal health information. It's also a secure, so we don't have to worry about things getting out into the open. That said, we're certainly not using clinical data that has not been de-identified. So let's move on. So where do I see libraries being in the loop with this, and librarians? So as you saw with our automated indexing, you have to continue to train these algorithms and to check them. And why do I see librarians and libraries as being the place for this? Well, because we have all of these amazing attributes here. So where we have expertise in information retrieval and understanding of search algorithms and how to optimize search and test search strategies. We also have critical analysis skills. I often look at my staff and I think, I envision them all with little Sherlock Holmes hats on as they get in there and start wading through things to just find an anomaly in some of the stuff we're doing, which is, it's entertaining, but man, they're good. So critical analysis skills to create some criteria to assess quality and the trustworthiness of the information being produced. They understand user needs. This was another interesting thing in working in ChatGPT and OpenAI, was we actually had to turn the parameters down. It was being too nice in our responses, and we had to make it a little more professional and not try to solve their medical issues. They understanding user needs, so really thinking about how to tailor services and responses to that unique type of customer that comes to them, and also the ability to assess accuracy and relevance in the information that's provided, and really thinking about some established quality benchmarking. So for all of these reasons, I definitely see our profession pivoting again. I believe that this is an inflection point, just like 28 years ago, almost 30 years ago, when PubMed went free. It was free, there was no charge. You didn't have to know how to do searching or use Boolean operators. And people felt like this is the end of being a health sciences librarian. And it's 30 years later and we still are in the game. So again, I think this is a new technology. We definitely have our work cut out for us, but I believe we have the expertise to assist in this new knowledge management and discovery platform.
Now it is time for the question and answers. First, I want to give an opportunity for our panelists to ask each other questions to start. We have 2 microphones on the table there, so no pressure, but you can ask each other questions. And then Stephanie is going to take the helm for questions that are online. There are no questions.
I think Stephanie
Well,
should-
I'd love to pose a question to Dylan about the really wonderful Ithaka SNR generative AI product tracker. So Dylan, I've used that resource maybe 5 times already in different consultations or presentations to different library user groups.
about it.
In what,
that you wanted
2
to ask?
weeks?
If not, I'll just say that We know that a lot of institutions are trying to decide what tools to support. We know that a lot of people who are interested in using tools are overwhelmed by the number of them that are coming out onto the market every day. We also know that those tools are of variable quality, and some of them are quite good and some of them are not so great. And so we decided to just start keeping track, not of every single one of them, but of the ones that seemed noteworthy and like they would potentially be useful for people to know about, either because we knew they were being widely used or because we thought they had really interesting potential. So we've created this list. We made it public a few weeks ago. It's getting quite a bit of use. We are committed to continuing to update it into 2025. At that point, we'll assess whether or not there's much need for something like this to continue. But really the idea was to just help people understand what LLMs the tools are drawing from, what databases they're using, particularly in scholarly contexts, where they're getting their information from, and what kind of basic functionality they offer when possible, what kind of data and privacy protections they afford. Sometimes that's quite difficult to discern, but we've done our best job there.
All right, Kate, hopefully that answered your question. We have several questions online and we'll try to get through as many as we can and also leave an opportunity for some of our at NAL attendees. So our first question is from Amanda Shu. At the dawn of artificial general intelligence, or AGI, how can we address the limitations of Gen AI, such as factual errors, inconsistencies, sensitive input to phrasing, hallucinations, and challenges in distinguishing real and fabricated information? And how will these limitations impact teaching, learning, and research at libraries?
I can take a crack at it. So again, I think because we're working behind, in a closed loop, we're not working with just an open version. So we have not seen any hallucinations in our data that we've been producing or evaluating. That said, when you do go online, if you're using the open version, and if you're just using some of the prompting on these platforms and not using controlled data, like we're using very controlled data through APIs saying, use these resources to address these questions. So I think there's a lot of possibility for things to go awry. It tries to be very helpful and make some interesting assumptions sometimes. But that's where I really think that having people that know how to check information and validate it, look at resources, and really track how an algorithm is producing what it's producing. To me, that is, again, that Sherlock Holmes mentality that many of our staff have. And I think as information professionals, that's where people are going to look to us to help, because they might not have the time or the resources or the know-how to assess some of the content that's coming out of these systems that or bots or whatever you're calling them, and what they're producing. So I don't have any recommendations on developing that expertise. I think, building data science types of skills so that you actually can do a little programming and be able to make some of these yourself so you can understand how things are working in the background, what's under the hood. I think that is a skill set that helps. And I think the other thing, which I don't know if you can teach or not, is just curiosity. And just wondering what's going on with some of these things and trying to either break them or assess them.
Okay, and Kate would like to respond as well.
Yes, I want to add something here.
Oh.
Yes, so basically when we talk about data always, and we are generating data, so it is synthetic data anyway. So that is there is a big problem there. It is called defect technology. You might heard of it. Like someone, my face will be changed to someone else's face, okay, through AI. So those data actually fake data. So to some extent, synthetic data, what we are making, that is fake data. So of course, in the metadata section, we have to mention that is synthetically generated so that there will be no confusion, because sometimes the data can be used in a wrong way, and that time it might generate not wanted results. So always, if there is a generating, we are generating data, we have to mention that is a synthetic data. And there are different technologies where we can watermark, or any other type of technology we can classify them. So we have to add those things too in future.
So I'd like to chime in with perhaps a different perspective. I think that there are some real limits to generative AI because the goal is creating plausible output, not accurate output. Generative AI tools are not a knowledge base. So there's a mismatch between the capacity of the technology and the goals that some tool creators and tool users have. Now, I'm of course willing to accept that the plausible output is better in terms of accuracy when you are using high quality training corpora like NLM uses, rather than using the web at large. But I still think that there's an information literacy aspect of this question that the participant was asking about how to handle generative AI output and train people or give people the tools to evaluate it.
Can I add one more thing on here? So the other thing that I failed to mention is that we actually have metrics and evaluation and assessment plans for each of our use cases to test. We're using the NIST AI risk framework to do the testing of what we're generating. So there is that as far as our use cases as well. Again, I just think there's a lot of potential with using these tools, but I think with a lot of the open data and not knowing exactly how some of these LLMs are put together, large language models, sorry, or even domain specific, what are all of those different pieces of data pulling together and generating. That is an interesting, well-kept secret that I would love to break into one day. But, for now, it's using the tools that are available to us. We're considering building our own language model to see, with the huge expanse of the NIH biomedical domain and just see what that would turn into and how to train that up. I think that's a pipe dream now, because I think, if you read about how much power generation, how much computing needs, and how many people you need to train these models up, it's probably excessive.
Great, thank you. Jennifer. Yeah. We'll need to be on the microphone. This is a comment from Jennifer Woodward Green, who does some AI work here at NAL.
Thank you. That was great talks. I really appreciate all of them. And just kind of to follow up on that question, because I think that's really kind of at the core of, you talk about inflection point. I think that's really a crux of where it is. And I'd be curious to see, like, looking at the AI tracker tool versus, what NLM is doing and working within your own data. And I know, like the Wikidata folks, there's been some presentations that one of the founders of there, they've just had their 10-year anniversary, and looking at just the compute needs, the speed of response for something that, like, tell me, famous person's birthday, that can be just in something like Wikidata. Once that's in there, it's never going to change. Whereas the large language model has to, every time it's asked, has to completely compute it from scratch. And people aren't really aware of that because it's still seconds in response. But it may not be the same person you were asking about if you aren't careful in land, because every time it regenerates. So I think that there's like talk about, Diane, about people having an understanding of what the tools are and how they're working. So I love the idea of the tracker tool, but I just wonder about your thoughts on, you know, that's going to talk about the metadata curation and interoperability and all those things that we're working on. But it's really, the large language model seems to be so, you know, in the front of everyone's mind that we're throwing out some of these really good, solid pieces that could actually, if we can, I feel like this is our time to make those strong knowledge graphs or whatever it is that we decide that is a source, you know, the API sources that you mentioned, that we know where we're going to run the model. But anyway, I'm just wondering what your thoughts on how you combine kind of everything you are.
Okay, you go ahead.
This may go in a slightly sideways direction, but I think that one of the things that makes generative AI in particular an interesting challenge from an information perspective is that while we kind of easily talk about integrity of inputs and then an integrity of an output, as you just mentioned, in a generative model, the output is not a stable, finite thing. It's a continuously moving object. And so I think it raises questions, first of all, on one side for librarians to really think about provenance as a more important kind of metadata now that needs to be transportable across a whole set of transfigurations and transformations of knowledge. But I think it also raises a lot of questions about what is the output we're talking about here, because it's being regenerated every time. There's good research documenting that the models actually are fairly variable in their quality from kind of day to day even. And it really does raise the question of being able to understand the fact that you get a good result from a model when you're testing it may or may not tell you all that much about what the model is going to do the next time it's asked a question. And so I think one thing we need to be thinking about is how do you attach, whether it's metadata or provenance information, things that can help legitimize and authorize knowledge through what's essentially kind of an endless loop in which input and output aren't really distinct things, especially if we end up in a world where more and more of the underlying data that AI is drawing from was itself generated by the large language models. We're in a new kind of loop that requires new ways of thinking about the segmentation of knowledge and how you track things in which this. Yeah, absolutely. Definitely not. Or a lasagna recipe, as the Post put it once.
I just want to add something. It's my personal experience. When ChatGPT came out, so everybody is interested. Oh, what a beautiful model! What it does. I started doing, some experiment. So I started. I remember I was searching some keywords to find some publication. How does it different from the Google Scholar I am using? I got some of the, I am saying almost a couple of months ago when ChatGPT was, in the very beginning. It was it was initial stage actually. So some publication came, those they do not exist. So that is a big question. Like, okay, this is good, but are those really helpful when we are applying them in day-to-day activity? So what I feel, we have to go a long way to reach that stage. What I feel, where it will be really, really helpful. What do you think? I mean, what is your experience?
So we are doing, so as you mentioned, every time you press the button, you can get a new response. And we've also modified how it responds by changing the parameters, the empathy level, or, I want it to be from a director's voice as opposed to a child's voice or whatever. There's a lot of parameters you can choose when you're playing, and it's called a playground, ironically. So, keep that in the back of your mind as well. I think one of the things that I am watching unfurl is the same people that are creating these. It's kind of like you can't be a programmer and do your own checking of your work, right? Because you just can't see anymore, those double Fs or the ofs or those and things, because you just don't see it any longer. So what I'm concerned about is, I was watching someone create their chat bot. It was for our grant portfolio work. And she was like, I don't like that result. And so she just kept pressing until she got one that she actually liked, which was entertaining, but also very telling because, there's a nice little bias creep, that just came out. Or where I see some of the areas that I'm concerned with is that, I want the results to meet my expectations. And so I'll create it to meet those expectations. Am I creating bias in there? Am I doing that from my own perspective of where I am, in the universe right now, as opposed to thinking of, other cultures, ethnicities and things like that. So that's where I have a little bit more concern about some of these things going sideways. That was a good choice of words. And I don't know how that's what we're pulling the NIST framework and going through, and there's several questions that you respond to as you're going through it, and they're really thought-provoking. I don't know if you've opened that up and taken a look at it, but there's a huge number of questions that you're supposed to think about. Will it be perfect? Probably not, but I think it's a great way to actually bring awareness to the tools and the bots that you're creating as you're creating them. The other thing is I really feel strongly that there has to be kind of an interdisciplinary team. I call them our tiger teams, because you need someone that's good with content management or content expertise, someone that probably has a little bit more tech skills. And so each one brings to the table different skills, and it makes it a little more rounded, and they challenge each other. Why are you asking for that? What are you trying to get when you're prompting this way? From my own experience in watching our teams unfurl, that has been a big help with changing some of the directions in the use cases and redefining the expectations, but also just bringing that collective knowledge to the table as kind of a checks and balances. We actually at NLM just put together a new team that's all about governance and looking at the ethics and bias that's coming into these. So our staff across the library are going to be looking at some of the products and outcomes and actually challenging to see if the results change or if there's any kind of bias introduced on purpose or unintentionally, or just ask questions about how some of these things were created and what their outcomes are producing. I don't know.
So we have about 3 minutes and many, many questions. So some of these we may have to respond to after the event. But one question that was somewhat answered in the chat is the checklists. And how can libraries partner with institutions to guide researchers to the resources that matter the most? Is this about curating lists? Is this training? Is this other types of assistance? Do any of you have some insights into that? And Kate, I would like to give you the first chance because you started responding in the chat.
Thank you. So this question is, how can libraries partner with institutions to guide researchers through these resources? And I think it's about partnering with multiple discrete user groups, the more you can tailor your approach to the interests and needs and terminology and goals of specific scholarly communities. And by that, it could be disciplinary, but it could also be clusters about methods, clusters about career stages, clusters about specific tasks people need to accomplish. The more particular you can, particularly you can work with specific communities, the better. And it's interactive. It's not just a one-off lecture, it's a series of conversations to understand the goals, the information goals and practices of these library users.
Do we have any other responses? Okay. I was going to say there's several questions that talk, and you did discuss this a little bit, Kate, but if everyone would like to talk more about how should data owners and libraries and other folks in this space collaborate together to make sure, I think even some of the questions are not specific, but it's just about making things findable and accessible and usable through AI. What might that look like? Yes.
Oh, I love this question. So I think for data providers or creators, my wish list for you is to use structured terminology that's semantically linked. So it makes sense, like earth versus earth or cold bird, cold virus. To me, disambiguating terminology in your data sets is a huge asset. The other thing is normalize your data and use, if you have common data elements or some kind of protocols out there that already have established values, don't reinvent the wheel, repurpose what other people have built so that there is interoperability across. There's probably a ton more that I can come up with, but you know, I always go back to that little cartoon where somebody was asking about getting data and the first field was SAM1, and they're like, oh, well, that was my grad student was Sam, and that's the first field. And and it gets worse from there. So, you know, think about how other metadata is structured and repurpose other models out there and extend where you have to, because, you know, the more you can repurpose and reuse, the better the data is going to be able to be used across other systems and products.
So I would say we are at time, a little bit over time, and I don't think we're going to get to all the questions, but what we are going to do is look through all the questions and hopefully plan future events and responses to these questions. Paul, I'll let you close us out.
Absolutely. I'd like to thank all of our speakers here in the room and online for participating today. We really appreciate your time and energy and insights and being able to be here with us for those who are in the room, as well as the hundreds or so folks who are online. And
Interpreter.
thank you to the sign language interpreters. And also want to thank again Stephanie and Jessica and Scott, who's running around, and Jean Guao, who is our associate director, who helped bring this program together today. And with that, thank you, and we'll see you next time.
Thank you, everyone.
Oh, Dianne wants to do something.
We have very appropriate gifts. So we have these really cool things that I'm not going to tell you until you open, but you've probably already experienced this through other people's retirements.
Oh, neat.
You got some old tchotchkes. We can't even get them anymore.
Oh, wow.
Anyway, this is a Lucite card. It's from our original card catalog. And I hope I picked an appropriate title for you. It's on insect entomology. So I thought that was kind of right up there with it. And we also have are the history and images of the National Library of Medicine. So Paul and I have hung out on our board of regents for many years together. And it's just been a pleasure, and you'll be sorely missed. He's been really a great partner and friend through so many years, getting through the pandemic and figuring out how we're going to make all of this work. And just, asking those really great questions when, I was getting a little out of control. So anyway, I'm going to miss you. So thank you.
Thank you, Diane. And before I start to cry, I think we'll end this program.
USDA is an equal opportunity provider, employer, and lender.